So it's our first string, and we're choosing a price for each fraction sum, and that means that we're choosing an amount of money to use as a whole that works really well with the fractions we're given. So here I'm given fifths and sevenths. There are so many numbers we can use here that are friendly. 70 pops in my head because 7 goes into 70 10 times, and 5 goes into 70 as well. Right? 5 goes into 70 14 times. And we can also use other numbers. In fact, there's no limit to the amount of numbers we're using. We're just picking multiples of each number. And we can also pick 35, for example, 35 cents, because 7 goes into 35 as well, and so does 5. So let's work with both here just to see that it doesn't matter, that this model is in fact flexible. So a fifth and seventh. Let's work with 70 first of all. What's 1/5 of 70 cents? Well, that's 14 cents, because 14 goes into 70 5 times, and that's what a fifth is. What is 1/7 of 70? Well, that's just 10 cents. So we have, and that's again because a seventh goes into 70 10 times. So we have 24 cents. And we would write this answer as 24 over 70, right? It's 24 out of 70 cents. Now with 35, we can write that as 7 cents plus 5 cents. And what I'm doing there is taking a fifth of 35 to find 7 cents, dividing 35 by 5, and dividing 35 by 7 to find a seventh, or 5 cents. And that gives us 12 cents. And it's 12 out of 35. So it looks like we have two different answers here. But you might notice that these are exactly the same. And one way to reason about that is to look at 24 and 12, compare them, and say, oh, 12 is half of 24, and 35 is half of 70. So these two fractions are equivalent. And you can see that no matter which amount of money we chose as our whole, our fraction might look different in the end, but we still end up with the same fraction, right? These fractions, 24 over 70, is proportional to 12 over 35. Meaning that, yeah, 24 is bigger than 12, and 70 is bigger than 35, but they're both twice as big as their corresponding parts, so it's still the same fraction. And we can move forward with this in the next problem. This time we can't pick 35, or we could pick 35, cents, but it's not so friendly to find a tenth of 35 cents. Instead, I'm going to use 70 cents. A tenth of 70 cents is just 7 cents, because 70 divided by 10 is 7 cents, and a seventh of 70 cents is 10 cents. Now we have 7 cents plus 10 cents, that's 17. So I write this answer as 17 over 70. Okay, and one more to go. And we're still working with fifths and sevenths. So I liked working with 35 because 35 is a smaller number, so I'm going to do that here. 35 cents. What's 1/5 of 35 cents? Again, you split that in 5 parts, so you divide by 5 to get 7 cents. So 2/5 is twice that, it's 14 cents. 2/7, of course, is twice 1/7, so it's 10 cents. 10's twice the 5, and that's 24 cents. So here we get 24 out of 35. And you see that we're able to always work with these fractions in terms of money if we find amounts of money that are friendly to both of the denominators. And there's no pressure. I mean, we don't have to find an amount of money that's we don't have to find a certain amount of money. Any amount will work. It just might give us a different looking fraction in the end. So we'll keep working with these in future videos.